Question 7 of paper 1 from the MATRIC AP MATHS paper deals with implicit differentiation. It's asking us to find the equation of this tangent which points in the positive direction at the point x is equal to 2. So they're asking us to find the equation of this tangent. One of the reasons that they give you a diagram for this type of question is because they want you to logic some things out. The first thing that we can see just by using logic is that we're not looking for the point x is equal to 2 and 0 because that's this point here. So we're not looking to calculate the gradient for that one. I mean the tangent, since that's the point where the tangent is pointing in the negative direction. So we're looking for this one here. We know that the point of contact is 2, some value of y. Our step-by-step procedure for this would first be to find the point of contact. So we need the point of contact. And then to use implicit differentiation to find the gradient. So in order to find the point of contact, we would substitute x is equal to 2 into the curve given in order to find the values of y that satisfy this. Before even completing this, we can expect that we're going to find some sort of a quadratic, since that there's 2 points which y is equal to when x is equal to 2. We have somewhat of a loop configuration. If we substitute x is equal to 2 into the curve given, we will find that it is 8 minus 2y is equal to 8 plus y squared. Then looking at this, we find that if we move this 8 to the other side, that will cancel out and give us 0. And if we move this 2y to the other side and rearrange, we'll get y squared plus 2y is equal to 0. And then factorizing that out, we'll get y into y plus 2 is equal to 0, which tells us that y is equal to 0 or y is equal to negative 2. As predicted by our kind of logic, we can tell that this point which they're asking us for is indeed in the negative y-axis. So we can confirm that this is most likely the point of contact we're looking for at x is equal to 2 and y is equal to negative 2. So the point of contact is then going to be 2, negative 2. That's the point of contact, just to abbreviate that. Next, we're going to examine this curve equation given to us and implicitly differentiate that so that we can find the gradient of that line and then use the classic intercept method to get the equation of that tangent. If we implicitly differentiate this, in other words, treating x as the variable of interest and y as what we're differentiating with respect to, then we will find that the derivative of 2x squared is 4x. Then we're going to need to use the product rule to differentiate xy. So in order to differentiate that, we're going to say that it's the derivative of x times by y. That's just going to give us y plus x times the derivative of y. The derivative of y is dy dx. Since we're only dealing with one variable, it's just dy dx, not the partial. Then this is then equal to 3x squared, which is the derivative of x cubed, plus 2y, which is the chain rule, and then dy dx. Sorry, the dy dx is by the chain rule. 2y is the derivative of y squared, and then the chain rule tells us dy dx. Do not forget the chain rule. The chain rule is very important in everything to do with calculus. To reiterate that again, when we have y squared and we differentiating this by with respect to y, then that's going to be 2y dy dx. Sorry, that should be dy dx of y squared, and that's that. Don't forget that. It's very important to always remember the chain rule when doing implicit differentiation. Then in our next line, we're going to do some simplification of this expression, and that's going to give us 4x minus y minus x dy dx is still equal to 3x squared plus 2y dy dx. Then after some simplification, which I'm going to leave out, some simple algebra, you'll be able to isolate dy dx, which is the end goal of this implicit differentiation, for you to isolate this dy dx, and you'll end up, once you've done that, you're going to be able to move the dy dx's to one side. So you'll have minus x dy dx minus 2y dy dx is equal to 3x squared plus y minus 4x. Then we're going to be able to factorize out this 2y minus x and then divide it on the other side, on this side here, and that's going to give us dy dx is equal to 3x squared plus y minus 4x all over minus x minus 2y, once we divide this over here and factorize the left-hand side. Now that we've gotten an expression for our gradient at the point of interest, we're going to need to substitute back in 2, negative 2. So this is the gradient of that whole curve. That's going to give us the gradient, because that's what we've achieved by doing implicit differentiation. When we substitute back in 2, 2, we'll get 12 minus 2 minus 8 over minus 2 plus 4, which is 2 over 2, which is 1. So now we know that we're going to have our gradient being of the form y is equal to mx plus c, but we know that m is equal to 1. Now we know we have 2 points we have 2, negative 2, and that's going to allow us to get our c value. So if we just plug that in, the 2, negative 2, we will then get that we're going to substitute it in. So we're going to substitute in 2, negative 2, sub that in. We're going to get minus 2 is equal to 2 plus c, which gives us that c is equal to negative 4. So from all of that, the equation ends up being y is equal to x minus 4. Just to reiterate the steps you need to take in this kind of a question, your first step would be to find the point of contact for the point you're interested in, being this one where the gradient is going upwards. The second step would be to correctly implicitly differentiate the expression given for this curve, being this one at the top right here. And in order to do that, we're going to take very special notice of the chain rule when we do this, not forgetting that each term containing the y is one where you need to pay extra special attention to the chain rule. And in cases where you find the xy, you need to realize that it's 2 rules that you need to employ, both the chain rule and the product rule. After doing the implicit differentiation correctly, you want to group the dy dx's together so that you can get the derivative term on its own. After doing some algebra and rearranging, you should find the term that gives you the gradient at any point along this curve. Then you want to substitute back in that point of contact, since we essentially want the gradient for this point of contact only, because that's going to give us the line. We in general know that in order to define a line in the Cartesian plane, we require the gradient and y-intercept. Once we've found the gradient, we're only left with one missing piece. Since we have two points, an x value and a y value, and the gradient, we're only left with the unknown being the intercept. Once you substitute in those x and y values, it becomes much easier to find that y-intercept. Then we substitute it back in and we find the equation of the tangent line, which was asked. Always remember in these types of questions that diagrams are not given for no reason. They're given to you to add some extra logic to how you should progress with the question in the most efficient manner possible. Although this question was worth quite a bit of marks, around 10 marks, I'd see no reason why somebody who would see this in a more efficient manner and skip the step of testing out at y is equal to 0, since you can visually see that it's going downwards, there's no reason for you to test whether that's going up or down. However, if you did not know which one was going up or down, the easiest way for you to check would to get both points of contact and test a point before and after. And obviously, if this value here is greater than that value, then it's going down. And if this value here is less than that value, then this is going up. So that's how you'd test if you didn't have a diagram. But since you do have a diagram, you know which point of contact is the one where it's going up, where the gradient is positive. And that about concludes this.